Hello, this is the Chapter 3 lecture for the newer edition, the 8th edition of Human Diseases textbook, and we're starting on infectious diseases. I'm going to be lecturing from the book, but mainly from the PowerPoint. I'm going to read the intro, and then I'll just basically be touching on the various topics here. I don't want to go into too much detail because you're all college age students and you can read, but I will highlight the high points of what I think that is important that you need to know. So starting on page 36, despite medical advances that have produced drugs and vaccines that are safe and effective, infectious diseases remain a major cause of death, disability, and social and economic upheaval for millions around the world. Illness and death from infectious diseases are particularly tragic because they are largely preventable and treatable. More than 90% of deaths from infectious diseases worldwide are caused by a handful of diseases. And it tells you to reference table 3.1 here. You don't have to know those percentages or anything like that, but it is interesting just to take a look at. The World Health Organization reports that in high-income countries, only one of the top 10 causes of death is an infectious disease. In contrast, among low and middle-income countries, infectious diseases account for 4 of the 10 leading causes of death. Poverty, lack of access to health care, antibiotic resistance, evolving human migration patterns, new infectious agents, and changing environmental and developmental activities all contribute to the growing impact of infectious diseases. So this chapter describes the nature of infectious diseases, surveys the types of microorganisms responsible for infections, and explains their transmission and discusses the treatment. Alright, so we will go ahead and begin. So your principles of infectious disease. I'm starting on slide number 6. These include pathogens. Pathogens is any type of disease, or it could be bacteria, virus, anything. Contagious, if it's contagious, meaning transmittable from person to person or from animal to person, person to animal, etc., etc. Communicable diseases, meaning that it will transfer from various routes of exit, like it could be in the sweat, it could be in saliva, some are just bloodborne, so it really depends. The epidemiology, the incidence, and the prevalence, those are all the 6 principles of infectious disease. I'm sorry, there's more, my bad. Going on to the next slide, we have terms, we have endemic, epidemic, pandemic, outbreak, and notifiable diseases. So let's go on and talk about all of these. Well, I'll let you look on page 36 and let you look at all of those terms. I believe I told you the first half of them. Epidemiology is a study of the transmission, how it's transmitted. Then we have the incidence of the disease, like, where it happened, what is the population like. The prevalence of the disease, how many numbers are accounted for that have the disease. An endemic, when this is like a very low number, is called an endemic. Epidemic is very high numbers and it's in certain populations. And then a pandemic is worldwide. Then we have notifiable diseases. These are diseases that physicians have to report to the CDC. So if you've ever worked in a medical office, anytime someone comes in with like Rocky Mountain spotted fever, chlamydia, gonorrhea, HIV, anything of that nature that's considered a communicable disease, it has to be reported to the health department, which in turn reports to the CDC, and there's like a little special form there that you would have to fill out. So going on to the transmission of infectious diseases, we have the reservoir, and the reservoir is, it can be a human, it could be an object, but it's whatever the the disease is on, whatever it survives in and lives in. So some insects can be reservoirs. We may have water that is a reservoir for, especially in low-income countries. And some of you mentioned that on last week's discussion board. Horizontal transmission, and this splits into direct and indirect transmission. So this is horizontal transmission is when it transfers from a reservoir to a susceptible human. Okay, and susceptible means that your immune system may be broken down, maybe from stress. You could have some type of autoimmune disease that may cause your immune system to be very low. In that case, you would be susceptible to diseases. Also, certain medicines like chemotherapy drugs and things such as that can make you more more commonly to have those conditions. So that's what horizontal transmission. And then we have direct, meaning you had actual interference with that reservoir host. And indirect maybe you were walking by the person that had the sickness, and it is spread through air droplet or water droplets or the air. So that's the difference between direct and indirect. It's kind of direct contact, indirect contact. Then it talks about fomites. These are just any kind of contaminated object. Okay, it could be a contaminated pen. It could have fomites on it. Then we have what we call vertical transmission, and this is when diseases are transmitted from one generation to the next. So let's say I have syphilis and I transmit it to my child, maybe during birth or shortly after birth through the birthing process. That is what we call vertical transmission. Maybe I have HIV and I spread it to my child either through birth or any other type of method. So that's vertical transmission, and usually during birth is the main type when we talk about vertical transmission. During birth, they'll take special precautions to try not to let the disease pass from the parent to the child, but sometimes it's just not preventable. And then we have the term parenteral. This means like through the blood, so injectable. So this is usually how your hepatitis B and C spread, your HIV and AIDS, and a few other diseases, but we won't list all of them. But parenteral is like by injection or through the blood. Going on to page 37, we have nosocomial infections. This is a hospital-acquired infection. Okay, so these we try to keep these down because the more infections that a hospital has, they have to what's the word I'm looking for? They have to report these infections, so they try to keep their infections down so they can keep patients coming. Unfortunately, it happens. It's hard when you as the medical professional are trying to keep everything nice and clean. However, you have to think you have patients there as well that may not be very helpful with that. Then going on to talk about normal flora on page 38. Normal flora is in our body, and it's like our good bacteria. It's what we need. And we sometimes when normal flora leaves the body from overuse of antibiotics or something such as that, it can be bad for our body and make us more susceptible to infection, especially hospital-acquired infections. You have another key term, microbiota. That's basically the same thing as normal flora. And then we talk about hand washing. Hand washing is the number one way to decrease infections, especially in a medical setting. So hand wash, hand wash, hand wash. Let's see. Let's go on to how to control infectious diseases. Well, first we have isolation. So anything that is airborne, like tuberculosis certain pneumonias or meningitis, we have to isolate the patient. And so if you're the healthcare worker, you usually have to put on protection from your head to the toes so you can remain isolated when you go in to take care of the patient and you don't get what they have. Usually they're not allowed to have visitors. Sometimes we put them in negative pressure hospital rooms so it doesn't get into the air very well. Quarantine, it's kind of the same thing. It's another word, but basically the difference between isolation and quarantine is isolation is like what we do in a medical facility. Quarantine, we want to keep all of these sick patients, there may be 15 sick patients, away from all the other healthy patients. So they're quarantined in their own areas. Disinfection. Of course, it's always important to disinfect. The more clean we can be, especially in a medical setting, the less infections that we may have. Then your book goes on to talk about bloodborne pathogens, and we've kind of mentioned that already, but we go into OSHA. There's certain things that OSHA requires, like hand washing, making sure we use gloves, personal protective equipment. So, and that protects us. You can look at Table 3 too. This is really good. It talks about hand hygiene and personal protective equipment and, how you should wear it or how you should perform it. So make sure you look over that when you can. Let's see. Let's go on to microorganisms. On page 40, we're going to start with viruses. Viruses are the smallest of all of the microorganisms. And viruses usually come on, they're very strong, you'll spike a high fever, and they last a long time, like the flu or influenza. That's an example of a virus. With that, we have a term called a latent infection. So this is basically where the virus will get into the cells in our bloodstream and they do not reproduce. And so when they don't reproduce, we may not get any symptoms, or we may get like a little bit, and then all of a sudden, a little while down the road, we get an infection. Maybe if stress is involved or, something like that. Let's see. Going on to bacteria. Bacteria come in three shapes. We have the round shape, and those are called cocci. We have the rod shape, those are called bacilli or bacillus. And then we have the spiral shape, which are called the spirilla or spirilla. So those are your three different types of bacteria and shapes. Also, bacteria have very different cell walls. They're very hard to penetrate. So we have to have a certain type of antibiotic. Sometimes we have to culture certain things to make sure that we're getting the right antibiotic that's strong enough to penetrate through the cell wall. Let's see. We can do, your book I believe talks about a gram stain dealing with bacteria. Gram stain is a common procedure, and basically we can stain it and to see what type of bacteria it is, and we can see more definition in the bacteria to learn more about what the patient may have. Let's see. Going on to protozoa. Before I go to protozoa, I do want to mention that I don't think that this book mentions, it does not mention anything much about rickettsia infection, but there is another type of microorganism called rickettsia, and that can cause certain diseases too, but it is another type of microorganism that is not really touched on too much in this chapter. So now going on to protozoa on page 42. These are single-celled organisms that have a nucleus. They're much larger than bacteria. So some of these protozoa have certain looks. Like a lot of them have tails called flagella They look like whip-like tails. So when you look at it under the microscope, you'll see tails. Sometimes you may see several tails. The main part of the protozoa can be flat. So I believe like the trichomonas infection kind of looks like a stingray under the microscope, and it usually has several little flagella. Sometimes they can have cilia, which is like little bitty tiny hairs that are all around the protozoa. Let's see. Going on to fungi. Fungi are very hard to treat. They're usually very stubborn. They can, if we have to use it long term, they can be very damaging to our liver. So when we have a patient on a long-term antifungal medicine, they have to usually have blood work. Let's see, fungi. I want you to look at the term called mycoses. This is another type of word, or the medical term for a fungal infection. Mycosis or mycoses, meaning more than one infection. Fungus, of course, lives off their host, so they really like the living host, and there's all different types of fungus. Let's see. Let's go on to helminths. Helminths is the fancy word for worms. So you can have roundworms, hookworms. Believe it or not, I know all of you have probably heard of ringworms, but that is actually not a parasite, which is another word for helminths, is anything parasitical. But one type of parasite is the helminth, which is the worm. But a ringworm, even though it's called worm at the end of it, it's actually a fungus. So that's really good to know. So the different types, let's talk about the hookworm, and I think it gives you pictures of all these. These can cause anemia. They're the largest number of cases in Africa, Latin America, Asia. There's a bunch of cases of these. So females lay thousands of eggs each day of hookworms, and so they develop and keep developing. So they're very hard to get rid of. Some of the symptoms that you may have are, just diarrhea, gastrointestinal upset, but we usually have to have a stool sample to be able to see if you have a certain type of worm. Then we have pinworms. Pinworms are the worms that are in the intestinal tract, and they usually only come out into the rectum at night. So in order to see if the patient really does have pinworms, usually we have to get a tongue blade and do the reverse sticky tape. And at night, when it's usually children that get this, when the child's sleeping, you can go in their undergarments and press around the rectal area, and then undo the tape and wrap it to seal the worms in the tape, and then you can take it into the office. And that's usually how we can find out if they have worms or pinworms. Let's see, prions. This is another type on page 44. Prions is it's an infectious particle, and it's like a little particle of protein, but it is infectious, and it looks kind of wormish like. They cause a lot of diseases, encephalitis, which is like fluid on the brain. Let's see, mad cow disease that affects cows, that's a type of prion as well. Let's see here. The treatment of infectious diseases on page 44. Well, antibiotics will treat most everything except virus. Viruses, it's a big no-no to do antibiotics. And unfortunately, that's why we're getting the antibiotic resistance. I don't want to go into too much of my soapbox about overuse of antibiotics, but if we do take antibiotics when we don't need it, when we actually do need it with a bacterial infection, they're not going to work, and then we're going to get more sick, and we're going to create this big superbug that no antibiotics are going to work with. So viruses, usually these are, how we treat them is palliative, and a lot of physicians, unfortunately, will give the patient antibiotics basically so they'll just shut up and go home, and it will make you better. It'll make your symptoms better, but it doesn't really make the virus go away. You just kind of have to play it out. So that's why we discussed antibiotic resistance. Let's see. Some talking about emerging and re-emerging infectious diseases. We're seeing a lot of re-emerging infectious diseases, mainly in children that because their parents have chosen not to get them vaccinated. Used to, back in the day, they didn't have a choice, but now you can parents can read all of this stuff and they choose not to get vaccinated, and then here we have an outbreak of polio again, or an outbreak of measles again. So it's very important to make sure that you always are up to date with vaccines. And then emerging is basically like emerging condition that patient or the physician may not know what it is, or it may not be in this country yet. So that's the difference between emerging and re-emerging diseases. Let's see. If you look on page 46 at table 3.3 and table 3.4, you can see some examples of different microbes. Here, the rotavirus. This is now vaccinated for in infants, and it's the little red juice-looking thing that they put under the tongue. So it's not like an injection, but it will help with a lot of those stomach viruses that can cause a lot of diarrhea and vomiting. I won't go into all of these, but you have the Ebola virus here that I've asked you about for your discussion board. H. pylori, hepatitis, H1N1. So make sure you look at all at those just to see the types of the new emerging infectious diseases and the ones that are re-emerging. This kind of brings us into the common vaccine preventable childhood infectious diseases. So I mentioned measles and mumps. We also have rubella, which is also known as the German measles. But that's all given together, called the MMR, and that's the big injection that everyone doesn't want their children to have because they've thought that one could possibly be leading to the autism. I won't go into that here. That could be a long story and a long debate. Diphtheria, tetanus, pertussis, DTaP, you may have heard it called DTaP or Tdap. That's diphtheria, tetanus, and pertussis. Pertussis is also called the whooping cough. We're seeing like a huge reemergence of this condition, and it's called a whooping cough because it makes the whooping sound when they cough. So again, vaccines. And then also the children that have gotten their vaccines, if they are exposed repeatedly to all of these conditions they've been vaccinated for, they may actually it may not be built up into their system good enough, and they may actually get the condition as well. You have some pictures in there of different things, like measles, what measles look like. They're like little small red hemorrhagic spots. Then we have tetanus, which we call like the TD shot. Tetanus, causes lockjaw. Then we have chicken pox. We usually vaccinate that at 1 year of age. We have the Haemophilus influenzae, which is short, we call HIB for short. We have polio, Streptococcus pneumonia. This is like the Prevnar injection. If you've ever heard of that, your doctor say Prevnar, or the pneumococcal, PCV. It's called all kind of different things, but you may have heard any of those terms, but that's what it covers, that bacteria, that pneumonia virus that can also cause meningitis. So those are some other examples of vaccines that can be prevented. And I believe Make sure you still, of course, read the chapter to learn about all of these conditions, because, of course, I don't have time to go into detail on each one, or my lecture would be several hours. But I just wanted to give you basically a rundown of the diseases that you're going to see, and the types of microorganisms that you're going to see in this chapter. If you look on page 50 through 53, the diseases at a glance, this is a great feature to this textbook, because it gives you every disease that was discussed and breaks it down. It tells you the disease, the signs and symptoms, the diagnostic tests that may be done, the treatment, the prognosis, and how to prevent it if it can be preventable. So that's a really good study tool. And then, of course, your all of your interactive exercises at the end of the chapter. So with that, we'll go ahead and call this one done.